try it, and you can let your u be the denominator here, and you get u is 2x. So this is wrong, so don't write this down. And then you, all right, let's derive this, and let's see, does it equal, not too far, 4x, that's potential, minus 1. But is there a multiplier that makes 14x plus 1? Yeah. It's not going to work. Yeah, there's no common multiplier. So this is wrong.
But do you get a mark for trying it?
I can't remember. I don't think you did.
I got a mark.
You may have got a mark for recognizing that it's integration or something.
I'm not sure how I got a mark, but I got
You may have got a lucky mark. All right, so now this is where we recognize the quadratic in the denominator can be split up into partial fractions, which some of you are not too sure of. So let's split this up into something over something over something plus something over something. Why do we do that? Well, it's very easy to integrate something like this because that's a ax plus b style one. But it's not easy to integrate when we got a squared in the denominator. So if we made them into two separate kind of rational functions, it would help. So how do we do that? Well, we do. Yeah, so I'm going to factorize the denominator first. That usually helps, over 14x plus 1. So if I factorize this, I get 2x, x, 1, 1. What's my signs here?
I think it's plus 1 minus 1.
Yeah, I think this, if for factorize my quadratic, that will work out. All right, so I want to convert that into something over 2x plus 1 plus something over x minus 1.
And you multiply it.
Yeah. Okay. So we've got to find a and b before we can even start to integrate. How do we find a and b? Well, this should equal 14x plus 1 over 2x squared minus x minus 1. So if we were to just solve, if you do this question, you say, right, what's my first thing? I'm going to get a common denominator, which is this times this. So I write 2x plus 1, x minus 1, multiply them together, and my numerator then becomes a times x minus 1, because this one has to be times by x minus 1, plus b times 2x plus 1. Now I know that that statement must equal this, and we already know the denominators are the same.
So you just have to find.
So we're really just working with the numerators. The denominators are the same because we made them the same. So we just solve this for a and b. So we get.
You would put the zeros in here.
Well, let's look. The one thing I know is the left-hand side has to equal the right-hand side. So I create two simultaneous equations. A plus b is equal to 1 from the constants, and a plus 2b is equal to 14 from the coefficients of x. So I use the constants. Oh, sorry, it should be negative a. This one, this one, this one, make the first one. And a, 2b, and 14 have to equal. So a plus 2b has to equal 14, yes.
That's not what the marks do.
I know. This is the way I would do it, because I think it makes the most sense. And it's the thing you'll remember. Because you just remember adding fractions and just solve.
I would be overwhelmed if I saw
That cancels straight away, the a's. And left with 3b is equal to 15, and then b becomes 5. So if b is 5, how do we find a? Well, we know negative a plus 5 now equals 1, because b is 5. So negative a is equal to negative 4, so a must be 4. Right, and now we're coming back. This a is 4, this b is 5. We come back to integrate finally. Now we can start integrating. I'll rewrite it with a and b now as 4 and 5. So it does no longer is written like this. It is written as partial fractions. A was 4, 2x plus 1, and b was 5x minus 1. And this is the thing that now I'm trying to integrate. Much easier to integrate this because I can just do ln. Okay, so how do I write? What is the integral of 4 over 2x plus 1? It is what? 4 ln 2x plus 1 divided by 2, because that's the a. So I put it there. And then I can write that's just 2 ln 2x plus 1. That's like a, okay. Do the same on the other one. Plus 5 ln x minus 1. Is there any need to rewrite this? No, okay. So I'll just, do we need a plus c here? No, it's a definite integral because we've got a half and 0 to sub in. So we have a half and 0 still to sub in. I think you might have got your attempt marks for the substitution of a half and 0 in, not the...
That's where I got that one
yeah,
mark.
recognizing that you have to sub in those and subtract. I think that's where you got your mark for, if you did that. Okay, so let's substitute in a half and substitute in 0 and subtract those two. So that's 2 ln. That's 2 times a half plus 1 is, yeah.
Would it be easier to name them
You could. I've already started this, so I'm not. Plus 5 ln a half. When I did this myself, I got it wrong because I rushed it. So what's a half minus 1? That's minus...
a half? Well, it's the absolute value.
Yeah, so it's positive a half.
Yeah.
So it's 5 ln a half. So that's with half in. Minus, so this is the half done, so minus 0, so that's 2 ln 1. We'll leave it at this, don't tell me this is going to equal something. And 5 ln 1. Remember, absolute value. Okay. Right. So, what's ln 1?
0?
You sure?
Sounds.
Sounds right?
Yeah.
Confused in the exam, what do you do? Write it out loud. If you're confused in the exam, just write it out. So ln 1 is equal to 0 for this reason. E to the power of what equals 1. E to the power of 0 equals 1. So this is 2 times, so this is just gone. Are we happy with that? This, on the other hand, is ln 2 squared plus ln, is this 2 to the power of minus 1 to the power, 2 to the power of minus 5? Am I right?
Root 5. Sorry, no.
Not root, no.
Half to the power of 5.
2 to the minus 5? 1 over...
I see how that works.
I did 2 to the power minus 1, and then I multiplied it by 5.
So is that correct?
Yeah, that's correct, yeah. And now we are adding these so we can multiply what's in. So we can multiply, this is fancy, but I think it's 2 to the power minus 3, is it? Yeah. It's 2 to the power minus 3 when you add the powers here. So using the log laws of addition.
So it's minus 3
Add-
ln 2, because it asks for a ln b.
Yes. So this is then minus 3 in front, ln 2. Let me check. Yes, minus 3 ln 2.
I feel like it would have been easier if we made them.
Yeah, possibly, but I started it, so I'm not going back. And that is, well, that's